What up? Today I'm gonna teach you how to do some math. And just wanted. Have you ever just wanted to do math one day because you're an introvert like me? You ever just wonder why you're doing math? You ever just wonder how to do math? You ever just wonder what are you doing? Okay, I'm gonna teach you what you do. I can't give you any applications or examples of what this could be used for in the real world. I can tell you it could be used for some interesting crap in the real world. Let's grab this. Lit! Yeah, I became this person in this day. Too lazy to even pick up a pencil. It's a pen. I'm too lazy to even say pen. But I just did. Okay, let's think accepting. Let's murder our dog. I want to think. Oh, right, graphing. I just thought of something, and it's called graphing, and it's super fun and exciting. Man, graphing. XY. Tell you one thing. This part, Y will be positive and X will be positive. We're just going to name this positive. Stay positive, guys. I guess. This part X will be negative and Y will be positive. And this part both are positive. This part Y will be negative, but X will be positive. You got all that? Here, pause the video to do this. Okay, moving on with it. Let's get a formula. Let's get a formula. So Y equals, what was it? I'm gonna try pulling an example. 3x. Why am I always using the letter 3? Like, whenever graphing something, I always use this letter 3. 3. I don't know why, though. It's always 3. What you do? Well, you kind of just mark the points of interest to you. Well, that's the way I was taught, I guess. If I can roll 5. So you basically solve for it. That's basically 3 times x, but writing it like y equals 3 times x plus 2. That makes no sense. So it's written like this. So 3 times 1 is, 3 plus 2 is 5. So you mark in between the two. Go up 1. Just going to go up 1 over 5. You mark the point. I don't know, I have the urge to just draw it and make it reach down to negative infinite. I haven't graphed for quite a while. And I'm moving on. Let's set it at 2. Oh, 2. So 3 times 2 is 6, 7, 8. Let's get good. Let's add 3, 9. So we got 9, 10, 11. Then it continues and continues and then it continues and continues and continues. One part's negative infinite, and one part's infinite. Yeah, I know. Graphing is fun. Tired. Moving on. X, Y. So we have our X, Y intercept. Well, You know what? I want to add something to this. I want to do double. Well, I think a linear is just straight line. Yeah, look it up and correct me if I'm wrong. But I'm pretty sure, I'm 99% sure a linear is straight line of a graph. Well, unless you're talking about if it has x squared, it's not linear. Well, my teacher told me that. I know. I'm only in 6th grade and she's telling me crap like this. But my teacher's a pretty good teacher, though. I gotta find out another formula. Here, let's put equals 4x plus 3. Then I'm going to teach you how to do square roots like this. Ooh, you never seen a square root like this. It's not, well, what is it called? It's not a perfect square. Ooh, spoopy. Yeah, I know, I'll teach you after these two examples. And this one we will actually deal with powers. So we got 4x plus 3. So how can we write that? 4. Here, let's get our little thingy out. This magical thingy. Well, it's a y to 1, you know. Do 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 do. Let's say y to 1. So x, that's 4, 5, 6, 7. 7. But then, yeah, you know, same thing, concept of this. Get into that later, you know. Yeah. Okay, moving on. Moving on with that. No. And let's see. See if we can get an intercept with these things. Okay, that'll be just great. 8, 9, 10, 11. I don't think the line was supposed to go that way, and I think they were supposed to be kind of like parallel and or the sign for parallel and go to negative infinity. I think. Correct me if I'm wrong. I haven't done this in forever, so scrap that. I think you should really solve for the infinite part of this. Well, once you get done with like this second or third point. I have 2. What part is that? I gotta mark it right here then. I mean, right here. Oh, wait a minute. I don't know. Maybe, because, wait a minute. Oh, that's in the 3s. So just cross over to here. I don't think these intercept. Well, I did a really bad job on graphing. I'm moving on with that. And a graph of x squared usually looks something along the lines of this. And there's a good reason why. Because 1 squared is 1. And yeah, so on and so on. Reason it's over on the plus minus side and everything, where y is a positive but x is a negative. Because, so basically, let's just this. Well, yeah, square root of, well, not the square root of -1. The square root of -1 is an imaginary number. But if you take the imaginary number square, you just get this. Yeah. stuff I've learned. Yeah. Like, -1 squared equals basically, what it equals is this. And -2 squared equals +4. Because here's why. Breaking it down in process just breaking it down in general or doing whatever. -2 times -2. Negative times negative is a positive. It's +4. Okay, let's get back to focusing. Graph of x to the third power usually looks something along the lines of this. Something like that. Yeah, I know, it's pretty weird looking. Next is this goes to negative infinite. This goes to positive infinite. Yeah, I know. Pretty cool, right? Alright, so square roots that aren't perfect. You all know square roots and everything, square root of 4 is 2 and everything like that. Well, say you had something like this. Square root of 5. You're like, hey, I wasn't like, what? Square root of 5? So my tip of advice really to do is to round close. We know 2 gets to 4, which 4 is like 1 away from 5. All you gotta do is just add 1. It's just literally 4 is that close to 5. So 2 squared is basically equal to 4. What does that tell us? Jesus. I had a heart attack. I forgot to turn my TV's volume down. Oh my god, it's all the way at 90. Jeesh. Oh god, I almost had a heart attack. Okay, moving on with that. Nobody cares if I did. That tells us something. It's gonna be into 2's. So let's start at 2.1 squared. I already know the answer, but let's just show you the process. And you just do, yeah, your average multiplying. And hey, you may be like, hey, that's very close to 5. Very. That's zooming a little too close. Yeah. But yeah, you may be like, that's very close to 5. Well, can we get any more close to 5? Usually, square roots that aren't perfect would usually look like, 1, 2, 7, 3, 9, 2, 6, 4, and so on, until they actually match numbers. So we're just trying to round to the closest using these two. And you're like, hey, let's do this. Solving square roots like this is just like, kind of keep repeating until you get the closest you can, I guess. Then you go to this, get another 4. Hey, you may be like, hey, another 4. Hey, I get another 4. So that would equal basically 4.84. Now, if you want to go any higher, like 2.3, 2.3, that would go over, 5 basically, where, basically, this gets really close to 5 and everything, like, super close. But the thing is, if we go any higher than this, we're going to end up still being at 5, but a little bit, well, we're going to be well over 5 by like a decimal point, or 0.1, or 1 point, I mean. So you may be like, that's 9, 0, ooh, that's 6, we got a, boom, we got a 4 right there, oh my gosh, that was placed perfectly. 9, 12, and you see what I mean? It's 5.29, so that couldn't be it. So our maximum limit is so far 2.2. So yep. One last thing before I do go, I'll teach you a little on imaginary numbers. I still need to study a little bit more about them, but hey, I know a decent amount to give some little clues of it. Next video I'm making is on trigonometry, thing, man. Okay, moving on. Imaginary numbers are kind of like this. Here, let's put this in negative 25. Well, since you can't really solve this because even if you put it on a calculator, it'll simply say air, or what's that, how you spell air? That's probably not how you do. Instead, that's when imaginary numbers come in. They could just be broken down to 25i. Break that down to 5i. Well, I think. Let me check. 1 second, I'll be right back. I do believe that is correct. Well, yeah, it is. So yeah, that could just be, oops. I mean, 5i basically could be equal to 5, well, times square root negative 1. And yeah, that's it. One last example using I squared. Remember on the back of sheet and everything, I squared equal to, well, negative 1. I was about to say positive 1. Oh, you guys will be in the comment section being like, hey, but you said, like, negative 1 earlier. Yes, I heard of my mistake. Negative 41 basically could equal, well, 41i. Let me give you another example. Oh crap, I meant squared. There we go. Which can basically be broken down, 41 times negative 1, which then equals negative 14, and yeah. That's it. That's what I want to show you. So yeah, now that you know, well, some more, hey, go home and everything and be like, hey, I just learned something interesting and everything. Yeah, see ya.